Every summer, millions of people around the world share the same sweet little habit. We bite into a juicy peach warmed by the sun, enjoy a bowl of crisp cherries, slice open a soft apricot, or crack open a fresh almond. And when the fruit is gone, almost without thinking, we throw the pit straight into the trash. We do it because we have been taught to see that pit as waste. It looks hard, dry, and lifeless. But anyone who has spent years working with soil, seeds, and trees knows that nature often hides its greatest power inside the smallest things. So the next time a peach pit, plum stone, cherry pit, apricot seed, or almond shell is resting in your palm, pause for a moment and really look at it. You are not holding garbage. You are holding a living tree in a dormant form. Inside that tough woody shell is a tiny embryo, quiet but alive, already carrying the natural instructions it needs to grow roots, push up a stem, form branches, and one day become a fruiting tree. With the right preparation, that pit you were about to throw away could grow into a tree that produces food for 20, 30, or even 40 years. It costs you nothing, but it can become a long-term gift for your garden, your family, and even the people who come after you. Welcome back to Earthly Delights, where we look beneath the surface of the soil and rediscover the old, practical wisdom that nature has been teaching for generations. If you have been throwing away stone fruit pits without a second thought, today is the day to see them differently. In this video, we are going to walk through a simple three-step process for turning the pits of peaches, plums, cherries, apricots, and almonds into young, living trees. This is not empty theory repeated from the internet. This is practical gardening knowledge built from real experience, with seeds, moisture, temperature, timing, and patience. Whether you have a wide homestead, a backyard garden, a small suburban space, or only a balcony with room for a few deep containers, this is something you can try. So instead of eating the fruit and throwing away the future, let's learn how to wake up the life hidden inside these stone fruits. Part 1. The biology of patience. To understand why so many people fail when they try to grow fruit trees from seed, we first need to understand how the seed itself works. Most of us are used to fast results. We put a seed into warm, moist soil, wait a week or two, and if nothing appears, we assume the seed is dead. But stone fruits do not follow our impatience. The seeds of the prunus family, which includes peaches, plums, apricots, cherries, and almonds, are built with a very old survival system. They are not designed to sprout the moment they touch moisture. They carry a natural protection mechanism called physiological dormancy. In simple terms, the seed is alive, but it is locked in sleep until the right season tells it to wake up. Think about a wild peach tree dropping its fruit during the hot days of late summer. The soft flesh breaks down, and the hard pit is left on the ground. If that seed germinated immediately after a late summer rain, the young seedling would be in serious danger. It would push up tender new growth just before winter arrived. Then frost, cold wind, and frozen soil could destroy it before it ever had a chance to establish roots. That is why nature built a delay into the seed. The seed is programmed not to trust warmth alone. Before it wakes up, it needs to pass through a long period of cool, damp conditions. It needs to experience a kind of winter. Only after that cold, moist period does the internal lock begin to open. This process is called stratification. In nature, winter handles it slowly over several months. At home, we have to recreate that winter in a controlled way. And this matters because once you understand dormancy, you stop blaming the seed for being slow. You realize it is not failing. It is waiting for the right signal. There is a lesson in that for every gardener. Real growth is not always visible right away. Some of the most important preparation happens in the dark, in the cold, and in the quiet. A seed may look inactive, but inside, it is preparing for spring. And sometimes, when life feels still, maybe we are not stuck at all. Maybe we are simply growing roots before the season of visible growth begins. Part 2. Step 1. Extraction and careful cleansing. The practical work begins with Step 1. Preparing the pit. The moment you finish eating the fruit, your job is to clean the pit properly. Every bit of sweet, sticky flesh must be removed from the outside of the woody shell. This step looks simple, but it is where many beginners lose their seeds before the process even begins. If pieces of fruit pulp stay attached to the pit, they will rot during stratification. And because stratification requires moisture, that leftover fruit becomes the perfect food source for mold and fungus. Once fungus spreads in a closed, damp environment, it can attack the shell and damage the living embryo inside before the seed ever gets a chance to grow. For a small number of pits, rinse them under warm running water and scrub them firmly with a stiff brush, a rough cloth, or a clean abrasive pad. Do not be gentle with the outside shell. You want it clean, with no slick film and no fruit fibers left behind. If you are working with a large batch of pits after preserving fruit or canning, there is a simple nursery-style method that works very well. Put the pits into a bucket, add a handful of sharp gravel or small rough stones, fill the bucket with water, and shake or stir everything vigorously. The rough edges of the stones scrape away the remaining fruit fibers and leave the pits much cleaner than rinsing alone. After washing, spread the pits on a clean paper towel and let them air dry for 24 to 48 hours at room temperature. Keep them out of direct sunlight. This short drying period helps stabilize the outer shell, but do not leave them sitting around for weeks. If the kernel inside dries out completely, the embryo can die. Now comes an important choice. Should you plant the whole pit, or should you remove the seed from inside? For peaches and apricots, the woody shell can be very thick. Nature can eventually break it down, but opening the pit by hand often speeds up germination. Inside is a teardrop-shaped seed that looks very much like a raw almond, but you must remove it carefully. Do not smash the pit with a hammer. One uncontrolled hit can crush the seed inside. A safer method is to use a small bench vise. Place the pit with the widest, flattest side against the jaws and tighten it slowly. When the shell cracks along the seam, stop and remove the seed gently. You can also use adjustable vise grips, but they should be set so they crack the shell without crushing what is inside. For plums and cherries, the shells are usually thinner, so you can stratify them whole. With cherry pits, lightly sanding one end with fine sandpaper can help moisture enter more easily and may speed up the process. One important safety warning must be clear. The inner seeds of stone fruits contain amygdalin, a compound that can break down into cyanide when digested. These seeds are for planting, not eating. Keep them away from children and pets. Part 3. The rebellion of the peel. Once your seeds are clean, and in some cases, removed from the hard shell, it can be tempting to plant them right away. But with peach and apricot seeds, there is one more detail worth understanding. If you look closely at the seed, you will see a thin brown papery layer wrapped around it. This layer is called the testa, or seed coat. In horticulture, some experienced propagators use a more advanced method. They soak the seed in cool water, then carefully nick and peel away that outer skin. The reason is simple. The seed coat is one more barrier between the embryo and the moisture and oxygen it needs to wake up. Removing it can make germination much faster. In clean, controlled conditions, peeled peach or almond seeds can germinate at a very high rate, sometimes approaching 95%. But faster does not always mean safer. That thin brown skin is not useless. It is the seed's natural protection. Once you peel it away, the embryo becomes exposed. It can absorb water quickly, but it can also rot quickly if conditions are too wet, too cold, or not clean enough. A peeled seed needs careful handling, good hygiene, and steady moisture control. This is something every experienced grower eventually learns. The barriers in nature are rarely accidental. The shell, the skin, the waiting period, the cold season, each one plays a role. They slow the process down, but they also protect life while it is still fragile. And the same lesson applies beyond the garden. Sometimes what feels like a delay is actually protection. Sometimes the slow process is what gives the roots time to become strong. If we try to force everything too quickly, we may expose new growth before it is ready to survive. Part 4. Step 2. Stratification. The chilled sanctuary. Now we move to Step 2. Stratification. Once your pits or seeds are clean and prepared, you need to create a small controlled winter. The easiest place to do that is inside the refrigerator. The goal is not to freeze the seeds. The goal is to keep them cold, slightly moist, and able to breathe. You need a medium that holds moisture without becoming soggy. A mix of 50% coarse sand and 50% coconut coir works well. Moist peat moss can also work. But for many home gardeners, the simplest method is the paper towel method. Take a clean paper towel, fold it, and moisten it with water. The most important rule is this: moist, never wet. If you squeeze the towel and water drips out, it is too wet. It should feel like a wrung-out sponge. Too much water blocks oxygen, and without oxygen, the seed can suffocate or mold. Place the seeds in a single layer on one side of the damp towel, fold the towel over them, and put it into a plastic storage bag or small container. Do not seal it completely airtight. Fold the bag loosely, or make a few tiny air holes, so gases can escape and a little airflow remains. Then place the container near the back of the refrigerator, where the temperature stays steady between 1 and 4 degrees Celsius, or 34 to 40 degrees Fahrenheit. This cool, dark environment tells the seed that winter has arrived. Each type of stone fruit has its own chilling requirement. Peaches, Prunus persica, usually need about 90 to 120 days of cold. That is why autumn is one of the best times to begin. Plums, Prunus species, usually need around 60 to 90 days. Apricots, Prunus armeniaca, often need about 77 to 100 days. Sour cherries, Prunus cerasus, usually need a longer and deeper chill, around 90 to 150 days at temperatures close to freezing. Sweet cherries, Prunus avium, generally need about 60 to 90 days. Almonds, Prunus dulcis, usually need the shortest rest, about 40 to 60 days. You can mark the calendar, but remember this important rule: the seed decides, not the calendar. Check the seeds once a week. If the towel begins to dry, mist it lightly. If it becomes too wet, replace it with a clean, damp towel. After enough cold time has passed, the first sign of life will appear. The shell or seed coat will split, and a tiny white root tip will push out. That root tip is called the radicle. The moment you see it, even if it appears earlier than expected, the seed has broken dormancy. The sleeping tree has awakened, and now it is ready for soil. Part 5. The silent enemy: mold, airflow, and the cinnamon contradiction. As soon as you begin stratifying seeds, there is one problem you must be ready for: mold. Every grower who has worked with seeds long enough has seen it. It may appear as a white, slippery film on the paper towel, or as a dark, fuzzy web spreading through the moist medium. And if you ignore it, mold can ruin weeks or even months of patient work very quickly. Mold is opportunistic. It does not need much to take over. If the temperature inside the refrigerator keeps shifting, or if the paper towel, peat moss, sand, or coir is just a little too wet, one tiny spore can multiply fast. In a closed, damp space, that mold can spread across the seeds and attack the surface before the embryo has a chance to grow. So if you see mold, do not wait and hope it disappears. Remove the affected seeds right away. You can sanitize them by dipping them for about 30 seconds in a diluted bleach solution, using 1 part household bleach to 10 parts clean water. Another option is to rinse them with standard 3% hydrogen peroxide to help kill surface spores without damaging the living seed inside. After that, clean the container well, throw away the old molded paper towel or medium, and place the seeds back into fresh, clean, lightly moist material. Now, there is a common home remedy you will see everywhere online. Sprinkle ground cinnamon on the seeds because cinnamon has natural antifungal properties. It sounds simple, and many people like the idea because it feels natural. But in real propagation work, this advice is not as reliable as it sounds. Ground cinnamon is not a controlled nursery product. The strength of its active compounds is not standardized, and it can bring extra organic particles into what should be a clean environment. In some cases, those organic particles may break down and actually give certain fungi more material to feed on. So instead of depending on kitchen spices, the better approach is to prevent mold the way experienced growers do. Clean materials, steady cold temperatures, good airflow, and careful moisture control. Before starting seeds, clean trays, pots, and containers. Keep the medium moist, not wet. Do not seal bags so tightly that the seeds cannot breathe. When seedlings are growing in pots, water from below when possible so the surface stays drier. A thin layer of sterile vermiculite on the top of the potting mix can also help. Vermiculite holds moisture lower in the soil while keeping the surface more open and airy, which makes it harder for mold to settle and spread. And there is a lesson here that reaches beyond gardening. We often want to solve problems by sprinkling something quick on the surface. But lasting improvement usually comes from changing the environment. Better airflow, less excess moisture, cleaner conditions, and stronger boundaries can prevent decay before it begins. Part 6. Step 3. Sowing and early care. Now we come to Step 3. Sowing and early establishment. Once your stratified seed has produced a clean white root tip, it is ready to leave the refrigerator and meet the soil. That little white tip is the beginning of the root system, so this is the moment when careful handling matters most. Do not take that fragile seed and bury it straight into heavy, compacted garden clay. Young stone fruit roots need oxygen. If the soil is dense, cold, and waterlogged, the new root can rot before the seedling ever reaches the surface. For the first growing season, it is much safer to start the seedling in a container where you can control moisture, drainage, light, and temperature. Choose a pot at least 20 centimeters, or about 8 inches, deep. Stone fruit seedlings often produce a strong taproot early, and that root needs space to grow downward. If the pot is too shallow, the root can hit the bottom too soon and begin circling, which weakens the young tree from the start. Fill the pot with a good quality, well-draining potting mix. To improve airflow around the roots, mix in about 20% coarse perlite. This keeps the soil lighter and helps prevent the wet, oxygen-poor conditions that young roots dislike. Make a small planting hole about 3 centimeters, or roughly 1 inch, deep. Now pay close attention to the direction of the seed. The white tip that appeared during stratification is the radical, the future root. It must point downward. If you plant it pointing upward, the seedling has to waste its stored energy trying to turn itself around. Sometimes it manages to correct itself, but sometimes it grows weak, twisted, or fails to emerge. Place the seed gently into the hole, with the root tip facing down. Cover it lightly with soil, and water it with room temperature water. Avoid cold water, because the newly awakened tissue is tender and can be shocked by sudden temperature changes. Keep the pot in a warm indoor place with bright indirect light or gentle morning sun. Do not put a baby seedling in harsh afternoon sunlight right away. At this stage, the plant is still soft and vulnerable, and intense sun can dry it out or burn the new leaves. Within 1 to 3 weeks, you should see the soil begin to lift as the green shoot pushes through. Soon after, the first leaves will open, and the seed that once looked dead will begin to look like a real young tree. When the seedling has developed 4 to 6 true leaves and is growing strongly, begin hardening it off. This simply means helping it adjust gradually to outdoor conditions. Start by placing the pot outside in a sheltered, shady location for about 1 hour on the first day. Then, over the next 2 weeks, slowly increase its time outdoors and introduce it little by little to more sunlight and wind. Once it can stay outside all day without wilting, you can begin feeding it lightly. Use a balanced liquid fertilizer diluted to half strength about once every 2 weeks. The goal is not to force unnatural growth, but to support steady, healthy development while the roots and stem become stronger. By the end of the first autumn, that tiny seed may have grown into a young tree 60 to 90 centimeters tall, or about 2 to 3 feet. At that point, it is no longer just a sprouted pit. It is a living tree, strong enough to begin preparing for its permanent place in the ground. Part 7. The genetic gamble, promiscuous pollination versus industrial clones. Now we need to talk honestly about one of the biggest questions in growing fruit trees from seed. Will the fruit be the same as the fruit you ate? If you buy a fruit tree from a nursery, it is usually a grafted tree. That means a branch, called a scion, from a known fruit variety has been joined to a separate rootstock. The top part is a clone of the parent tree. Because of that, grafted trees are predictable. You know the fruit size, the flavor, the harvest quality, and in many cases, the tree can begin producing fruit in 2 to 3 years. A seed-grown tree is different. When you grow a tree from a pit, you are growing a new genetic individual. Because of pollination and sexual reproduction, that seed carries a unique mix of DNA. Permaculture grower Joseph Lofthouse often talks about this kind of open, mixed pollination as promiscuous pollination. In practical terms, it means the seedling will not be an exact copy of the fruit you ate. A pit from a sweet store-bought peach may grow into a tree that produces fruit with a slightly different size, flavor, texture, or harvest time. It may take 3, 5, or even 7 years before you taste the first crop. That is the gamble. But there is also a strength in that gamble. Cloned trees give predictability, but too much cloning can create weakness in a larger growing system. When many trees or crops share the same genetic makeup, one disease or pest can sometimes spread through them more easily. Seedlings, on the other hand, bring genetic diversity, and diversity is one of nature's strongest tools for survival. Seed-grown trees often have strong juvenile vigor. When they are raised well and planted properly, they can develop deep, powerful root systems. A seedling that grows from its own roots may become hardy, adaptable, and better suited to the local soil, weather, and pest pressure around it. And here is the encouraging part. Many stone fruits can produce surprisingly good seedlings. Peaches, nectarines, and apricots are often self-fertile, so their genetics may not drift as wildly as some people imagine. If you plant a pit from a high-quality fruit, there is a real chance the tree can produce fruit that is delicious, sweet, refreshing, and close in character to the parent. It may not be identical, but it may still be worth growing. And there is a beautiful reminder in this. In life, we are often pushed to become predictable, standardized versions of success, like grafted clones made to fit one model. But seedlings teach a different lesson. They take more time. They carry more mystery. They do not always follow the expected shape. Yet they can build deep roots, adapt to their place, and offer a flavor that is completely their own. Part 8. The Permaculture Guild, the Circle of Allies. Once your young seed-grown tree is ready to move into the ground, it is time to think beyond simply digging a hole and walking away. A fruit tree should not be treated like a lonely object standing in bare soil. In many industrial orchards, trees are planted in straight rows, surrounded by short grass, exposed ground, or chemically managed spaces. But that is not how nature builds strength. In a healthy forest, no tree grows alone. Every tree stands within a living community of roots, fungi, insects, herbs, fallen leaves, and soil organisms. That is the idea behind a fruit tree guild. A guild is a group of supportive plants and natural materials arranged around a tree to help it grow better. When done well, it can reduce weeds, feed the soil, support beneficial fungi, attract pollinators, shelter predators, and reduce pest pressure without constant chemical inputs. You can begin a simple fruit tree guild in 3 practical steps. Step 1. Sheet mulch for mycorrhizal networks. Start by clearing grass and weeds in a circle about 4 feet wide around the young tree. Grass is a strong competitor, especially for young fruit trees, because it steals moisture and nutrients from the upper soil. Lay down cardboard or thick paper over the cleared area to smother weed growth. Then cover it with about 4 inches of organic mulch, such as wood chips, fallen leaves, coarse compost, or a mix of these materials. Keep the mulch a few inches away from the trunk, so moisture does not sit against the bark and cause rot. As the mulch slowly breaks down, it feeds the soil. It also supports beneficial fungi, including mycorrhizal fungi. These fungal networks connect with plant roots and help expand the root's reach. They can help the tree access water and nutrients, including phosphorus, that may be locked deeper in the soil. In return, the tree shares sugars made through photosynthesis. This is one of the quiet partnerships that makes healthy soil so powerful. Step 2. Plant the nitrogen fixers next. Add nitrogen-fixing plants under or near the tree canopy. Good choices include lupines, white clover, or suitable nitrogen-fixing shrubs for your climate. These plants work with specialized soil bacteria that can take nitrogen from the air and turn it into a form plants can use. As their roots grow, leaves fall, and plant material breaks down, they help feed the soil naturally. Over time, this creates a gentle, ongoing source of fertility around the fruit tree. The key is not to crowd the young tree. Use these plants as living support, not competition. Keep the area balanced and manage growth when needed. Step 3. Biological pest suppression and habitat design. The third step is to invite allies into the garden. Around the edge of the canopy, plant aromatic herbs such as garlic chives, mint, sage, or lavender. Their strong scents can confuse certain pests, like aphids, while their flowers can attract pollinators and beneficial insects. You can also place a small pile of rocks or old logs on the cooler, shaded side of the tree. This creates shelter for ground beetles, predatory insects, frogs, and other helpful creatures. Many of these natural predators move at night and feed on pests that would otherwise damage young leaves and shoots. Comfrey can also be included if it suits your space. It has a deep root system that can draw minerals from lower layers of soil, and its large leaves can be cut and used as green mulch around the tree. When you build a guild, you stop thinking of the tree as a single plant. You begin to see it as the center of a living circle. The mulch protects the soil. The fungi connect the roots. The nitrogen fixers feed the system. The herbs attract life and confuse pests. The logs and rocks provide shelter for natural defenders. Together, they create a small ecosystem where the tree has support from every direction. The seed in your hand today. We have followed the full journey of a stone fruit seed, from something most people throw away to the beginning of a living orchard. We looked at why these seeds need patience. We learned how dormancy works, why cold and moisture are necessary, how to clean and prepare the pits, how to handle mold, how to sow the sprouted seed correctly, and how to support the young tree as it grows. We also talked about the genetic gamble of seed-grown trees and the strength that comes from diversity. And finally, we saw how a young tree can become the heart of a small permaculture guild, surrounded by plants and soil life that help it thrive. So the next time you hold a peach pit, a plum stone, a cherry pit, an apricot seed, or an almond in your hand, pause before you throw it away. Look at it closely. Feel its weight. It may look small and ordinary, but inside it is a living promise. You can throw that promise into the trash, or you can give it a chance. You can choose the slow, patient path of working with nature. You can learn to wake the seed, guide the root, protect the young plant, and one day stand beside a tree that began in your own hand. If this video gave you something useful, and if it made you look differently at the pits you used to throw away, subscribe to Earthly Delights. Turn on notifications so you do not miss the next practical, field-tested gardening guide. And now I want to hear from you. Which stone fruit pit are you going to try first? Peach, plum, apricot, cherry, or almond? Leave the name of the fruit in the comments. I read every comment, and I would love to know which sleeping trees we are going to wake up together. Thank you for spending this time in the garden with me. Keep your hands in the soil, keep learning from nature, and remember this: abundance is often hiding inside the smallest things we almost throw away. Until next time, happy growing.